area of a sector, area of a segment, and length of an arc. So we are looking at 2-3 concepts over here. Nothing to buy out, it's just to introduce you to the idea of how does a sector look, how does a segment look, and what are the names and formula associated. So it's all something which you already know. Okay, it's just the name associated with that, and it's very simple. Okay, so I have a circle of radius r. So we'll begin with that, and I'll take it as small r. Apparently, I'm writing small r in this chapter. So we have OA and OB are radius, right? The angle subtended by this two length is theta. Now, what is the sector? Sector is this region, right? And also this region. So, I mean, it's kind of confusing. I mean, both the regions. Well, this is known as minor sector. And obviously, this will be known as major sector, right? Now, what is a segment? Take any chord, right? This is a chord. So, I'll call this as MN. MN is a chord. Okay. Let me mention it over here. Is a chord, right? So, this region is a sector and the other part is also sector. And yes, as usual, this is what? Can you guess? Correct. Minor segment. Sorry. I think I was telling sector. My bad. These are segments. This is a minor segment and this is a major segment. Right. Next, I'll show the arc concept also. So length of an arc. So, but what is an arc? If when you are entering into a place, any city or a town or a village, you get this structure. I've seen this. It's a name board kind of thing. This particular village is welcoming you and all of that. People of this village welcomes you, right? And when you're exiting the village, they tell, thank you for visiting and stuff like that, right? So that board is an arc. Okay, that's an example of an arc. So basically, if you start at a point and run along the length of the circumference, that creates an arc. From here to here is an arc. So I can tell it is along, it's part of a circumference. Yeah, the vague definition is part of a circumference. Okay. Now, let's look at the formula. See, the formula idea is very simple. It has to do with proportionality. So let me show it this way. Say I have a radius, right? If I swipe this entire region, okay, if I swing this in this entire region, what is the degree I covered? So basically, I went from here and came back to this place. So how much degree did I cover? 360 degree. What is the area I swept? What is the region I swept? For an angle of 360 degree, I swept an area of pi r square, is it not? Entire circle, right? Now, for an angle of theta, how much region will I sweep? That's the whole idea. Okay. So if I have an angle of theta, how much region will I sweep? Will I be sweeping? So that we can take it as x. And one more question to you guys, a commonsensical question. If I increase the angle, say from here, if I increase the angle, will my area be increasing or decreasing? My area will be increasing, is it not? So basically, angle and the area, right, minor sector area, have a directly proportional relationship. Even actually major sector also, but anyways. So in this case, theta is being measured in the minor sector. So, right, so all of this thing we are talking about is in regarding to minor sector. Remember that. Now, coming back, since angle and area are directly proportional, so we'll tell as angle and area are directly proportional, right? What you can write is cross multiply x into 360 is equal to theta into pi r square. So you divide with 360 both the sides, right? We want x, is it not? So x is equal to theta by 360 into pi r square. And this is your area, basically. Theta by 360 into pi r square. Don't by heart this. It should be something which should be commonsensical. Okay. Now, what will be the area of major sector? Well, if I don't know the area of, angle of that, all I have to do is subtract the area of the circle with the area of the minor sector. So in this case, theta by 360 into pi r square. Okay. So all this is something that you will calculate and see. It's just an introductory topic. Don't by heart anything from here. Now, minor segment. How will we calculate that? See, if I join this entire region, right? This we are looking at a triangle plus this region forms a sector. So basically, this entire region is a sector, minor sector. So I can get a minor segment by, right? Can you guess what? Minor segment is equal to minor sector, making an angle of theta minus what? What should I subtract? Area of triangle OMN. Is it not? So basically, if I happen to subtract this particular area, right, I'll get the area of the minor sector. But how will we calculate this area? Majority of the times we use trigonometry. You can use Heron's formula. You can use half into base into height and many ways. Okay. So depending on the problem, I'll be showing it to you. So I told you, we are not trying to by heart anything over here. It's just an introductory phase, right? So it is basically calculation oriented. It's not formula oriented. It's not something you can mug. Depending on the situation, you'll use different formulas or things to calculate this, right? Now, length of an arc. I hope you guys can figure it out. It's not too hard. If I have a length and if I sweep one entire region, okay, right? If I go one entire round, the I'll be covering the circumference of the circle. If I want to find the length of this swipe, it's nothing but circumference of the circle, is it not? So again, I'm looking at angle, relating it to the length. So if I swipe 360 degree, if I run 360 degree, I'll be running for a length of 2 pi r. Here I'm using capital R. It's just variables now, so I keep varying small r, capital R, doesn't matter. If I have an angle of theta, how much length will I be running? Same thing, cross multiply x into 360 is equal to 2 pi r, theta into 2 pi r, 360 both the sides. And so x is equal to theta by 360 into 2 pi r. And this is your formula, right? Again, don't by heart anything. It's as and when you get, you need to use the idea of proportionality and figure out the required formulas. And it should not be fixed. This is the method to solve this. Now, the idea should flow. That's how you learn something. You don't sit and by heart everything. It's not practical. Okay. So you need to increase your IQ, not your memory queue. Right? So please learn conceptually, not just memorizing something.